Assalamu alaikum. Good morning, dear students. Today I'm going to be delivering the lecture about the Aufbau principle. And Aufbau principle is very important when you're studying chemistry, especially in grade 10, 11, and 12. It starts from there and it's going on towards the university level. So students are having problem in understanding the principle, but inshallah after watching this video you will not be facing any problem in that. So Aufbau is a German word actually, which means that arrange something in increasing order or ascending order, right? So you're going to start from the first shell, moving into the second shell, third and fourth, and then fifth and seventh, sixth and seventh shell. So this is how you're going to work on that, and you're going to put the electrons. Basically the rule is about the electronic configuration. So once you watch this video, inshallah, you will understand that how important this rule is and how easy this rule is. There is a sequence which you're going to follow about it, and that sequence is like 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d10. So that's the sequence till Krypton. You're going to be using the sequence, and when you reach to the configuration of chromium and copper are not following the Aufbau principle. So 4s and 3d, they are changing their electrons, switching their electrons, where 4s is having 1 electron, and for chromium I'm talking about, and 3d is having 5 electrons. And the same case is there for copper, where 4s is having 1 electron and 3d is having 10 electrons there in it. Okay, why this is happening? The reason for that is that chromium is highly stable, and along with copper is also stable. So naturally when elements are stable, you need to apply the stability rule on it. And the stability rule here is that we have to have either completely filled orbitals, or we need to have half filled orbitals. 4s, when we talk about it, or any s orbital, when it is having 1 electron, it is half filled, having 2 electrons is completely filled. But 3d or any d orbital, if it is completely filled, will be 10 electrons, and half filled will be having 5 electrons. So that's why this rule is applicable there. So you can see and follow with me in the connected video, inshallah, and you will enjoy that. So let us begin this rule, the Aufbau principle. This is the Aufbau principle. And how does it start, and how will you make the diagram for the Aufbau principle? You know that there are shells. So shell number 1 is having s orbital only. Shell number 2 is having s and p orbitals. Shell number 3 is having s, p, and d orbitals. Shell number 4 is having s, p, d, and f. Shell number 5 also goes with s, p, d, and f. Shell number 6 goes with s, p, and d. So this is how we are going to be writing this rule actually. So now how to fill out the electrons there in it. The first step is electron will go into the first one, then it goes into. This is how we are going to follow the rule. Okay, so you can see here the rule is starting with 1s2, 2s2, 2p6, then it goes to 3s, 3s2, then 3p6, then it goes to 4s, and moving on to 3d here, 4s2 and 3d10. So most of your configuration is done actually. Right, so this is how we are applying the rule. Once again, let me repeat this part. Okay, and you can see here once again how I'm doing it. First the electron goes to the 1s, then it goes to 2s, then it from 2s to 2p, and then 3s, 3s to 3p, 4s, 3d, and it goes like this, right? So this is how we are working on this rule. This is a very important rule, and you can work out different elements and different electronic configuration on it. Okay, so simply let's start with 1s, 2s, 2p, 3s, 3p, 4s, and 3d. That's the rule. The overall till grade 12 applicable there. Okay. S can accommodate how many electrons? 2. And if I'm showing that according to Hund's rule and Abba principle, one should be up, the other should be down. P can accommodate total of 2 times 3 orbitals are there. So 1, 2, and 3, and then down, down, and down. Okay, moving on to D. D is of 5 kinds, and we can have 1, 2, 3, 4, and 5. So up, 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 and up, half filled, and then we have completely filled. Right? So this is how it's working. This is a very important rule actually. Okay, so if you see chromium, the electronic configuration for chromium is having 23, the atomic number. So I'll go for completing this number. 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, and 3d 5. Okay, this is the correct version, and the wrong version could be, when I'm following the rule, it will go as 4s2 and 3d 4. So this one is totally wrong. We don't support this. This is correct. The reason is that half filled and completely filled orbitals are stable. Okay, keep that in your mind. Right, so now what is half filled and completely filled? If S is there, one electron is half filled, and if S is having 2 electrons, is completely filled. Okay, in case of P, we'll be having 3 electrons and 6 electrons. Here, in case of D, for half filled it will be 5, and completely filled it will be 10. This brings stability to the elements. Right, when I'm working for copper, Cu, 29 electrons are there in it. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, and 3d 10. Okay, this is the correct version, and the wrong version will be 4s2, 3d 9. So this is wrong and this area is correct. Thank you very much. Keep watching more videos and join us the channel for much more appreciated videos of